Alright, let's consider construction of a quadratic equation with given roots. When a particular problem is given in a quadratic equation, after solving, we obtain two results or two answers. Here we can say that x is equal to this or x is equal to that. These two answers obtained is what we call the quadratic roots. The quadratic roots. Again, in mathematics, it is possible to resolve from these quadratic roots, from these two results given, back to the original equation with which it was given. Now, resolving from these quadratic roots to the original equation is what we call the construction of the quadratic equation with given roots. Now, when the quadratic root is given to us, there are two basic methods that can be used to obtain the original equation. The first is this. So, let's consider this example on the board. X is equal to minus 2. I beg your pardon. X is equal to 2 and x is equal to minus 7. The first root on the board is x is plus 2 and the second root is x is minus 2 on the board. First thing first, let's examine the first root by equating the first root to 0 or by a collection of like terms. First thing first, from the first root, x is equal to 2 and x is equal to minus 7. So we have bringing the constant term over to the left hand side and equating to 0. We have x, when this person crosses over, it becomes minus 2 is equal to 0. Let's do the same here. And x, when minus 7 crosses over, it becomes plus 7 is equal to 0. So we have x minus 2 and x plus 7. X minus 2 is equal to 0 from here, and x plus 7 is equal to 0. The next step is to bring the two parentheses, bringing the two brackets together and equating all of them to 0. So we have x minus 2 and x plus 7 is equal to 0. So we can expand this. If we have, for instance, if we have a plus b and x plus y, to expand this, we can either solve using the first step in the first parenthesis to multiply with the second bracket. So we have a, bringing this person out, then multiply by this person, x plus y. Again, bringing the second term out from the first bracket and multiply by this same person, plus b x plus y. Alright, that becomes a times this, ax, a times this plus ay, plus b times this, bx, times this times this, plus by. So let's bring the same knowledge over to this place. So we have, in the first bracket, we have x, bracket open, x plus 7, plus 7, minus 2, bracket open, x plus 7, x plus 7 equal to 0. X times x gives x squared plus x times 7 is 7x minus plus 7 gives minus 14, which equals to 0. Alright, x squared, by collection of like terms, 7x minus 2x will give plus 5x minus 14 equal to 0. Therefore, the quadratic equation is given as x squared plus 5x minus 14 equal to 0. Now, after solving this, from the construction of the root to a quadratic equation, we obtain x squared plus 5x minus 14 is equal to 0. That was basically the first method. Now, the method number 2 to solve this is by using the general formula x squared minus sum of roots plus product of roots. This is equal to 0. X squared minus sum of roots plus product of roots equal to 0. Alright, let's examine this. To get the sum of root is given as the two numbers are, or the roots are plus 2 and minus 7. So the sum of roots becomes plus 2 plus sum means plus 2 plus minus 7, which equals plus 2 plus times minus gives minus 7. So we have plus 2 minus 7 is minus 5. Alright, and the product of roots becomes product means times is the first root is plus 2 times minus 7. Plus 2 times minus 7 gives minus 14. Okay, we can substitute this and this into the formula. So the formula is x squared minus sum of roots x plus product of roots. So we have, let me write this, x squared minus sum of roots times x plus the product of roots, which equals to 0. On the board we have x squared minus sum of roots on the board is minus 5. So we have minus 5 times x plus, and the product of roots is minus 14 plus minus 14 equal to 0. So we have this x squared minus times minus is plus 5x minus times plus times minus rather means minus 14, which is equal to 0. So we can use either the first method or the second method to obtain the quadratic equation. Either of the methods used must lead to the final or the right result. So let's consider the next example. X is equal to plus 3 and x is equal to minus 2 over. This is quite different from the preceding example that was solved. So in this example, we have a whole number as one of the roots, and the second root is a fraction. Alright, using the first method or using the first approach, x is equal to 3 and x is equal to minus 2 over 3. First step is to bring the constant term over to the left hand side and equate this to 0. So we have x, when this person crosses over, it becomes minus 3 is equal to 0, and x, when minus 2 over 3 crosses over the positive sign, becomes plus 2 over 3. This is also equal to 0. So from the first root, we have x minus 3 is equal to 0, and the second root, we have x plus 2 over 3 is equal to 0. Alright, there is a simple method, or there is a shortcut method that can be used to take up the fraction in the second root. And the method is by dividing the x by 1, then cross and multiply. So this goes to this, and this also goes to this. So 2 times 1 gives 2 plus x times 3 gives 3x. This is equal to 0. So this and this are basically the same thing. Therefore, the next step is to enclose both of them in brackets. We have from this x minus 3 bracket close equal to 0, and 2 plus 3x in bracket also equal to 0. Next is to bring the two brackets together and equate to 0. So we have in the first bracket x minus 3, and the second bracket 2 plus 3x. 3x is equal to 0. So we can expand the bracket. This times this gives. So to expand the bracket, let's bring this one over again. Here we have x plus y and a plus b. So if you have this, it becomes x bracket open a plus y bracket open a plus b. Using the single term in the first bracket to multiply the second bracket. The first term times the entire bracket plus the second term times the entire bracket. So doing this, we have x times a gives ax, and x times y gives plus xy. Y times this gives ay, and y times b gives by. Alright, let's take the technology over to this piece. We have x in bracket 2 plus 3x minus 3 in bracket 2 plus 3x equals to 0. X times 2 gives 2x plus x times 3x gives 3x squared minus 3 times 2 gives minus 6, and minus 3 times 3x gives minus 9x equal to 0. Let's collect like terms. By collecting like terms, starting with the term with the highest power, which is x squared, so we have 3x squared plus 2x minus 9x minus 6 is equal to 0. So we have 3x squared plus 2x minus 9x gives minus 7x minus 6 equal to 0. Therefore, this is the general solution for the answer. Therefore, this is the general solution for the construction of the quadratic equation when the roots are +3 and -2 over. So let's consider the same example. Construction of a quadratic equation with given roots using the method number 2, where the formula is applicable. So the formula which can be used for the method number 2 is given as x squared minus sum of roots times x plus product of roots equal to 0. So the first root on the board is -3, x is equal to -3 and x is equal to +2 over 5. So to obtain the sum, to obtain the first bracket in the formula, which is sum of the roots, sum of roots, it becomes -3 plus 2 over 5 minus the first root plus the second root. Alright, so we have here as -3 plus 2 over 5. This is the same as -3 over 1 plus 2 over 5. So we can provide numerator and denominator to both terms. We can make them into that fraction. This is equal to -3 over 1 plus 2 over 5. At this point, we have to determine the LCM of the denominator. And the LCM of the denominator is the LCM of 1 and 5 is given as 5 all over LCM divided by 1 is 5, and 5 times the numerator, which is -3, gives -15 plus the LCM divided by the second denominator, which is 5 divided by 5 is 1, and 1 times 2 gives 2. So we have -15 plus 2, and -15 plus 2 is -13 over 5. Therefore, the sum is -13 over 5. Let's consider the second bracket on the formula, which is the product. Product means times. Therefore, we are multiplying the first root with the second root. And the first root is -3 times the second root is 2 all over 5. So this is basically as 3 over 1 times 2 over 5. This gives -3 times 2. We multiply the numerator. This is not the same as the previous one that we did. -3 times 2, which gives -6, divided by 1 times 5 gives 5. Alright, so this product of the roots is given as -6 over 5, whereas the sum is -13 over 5. So my sum is given as -13 over 5, and the product is given as -6 over 5. Let's rewrite this. So we have x squared minus sum of roots is given as minus 13 over 5 minus 13 over 5 times x plus the product of roots is given as minus 6 over 5 minus 6 over 5. This is equal to 0. Bringing this, x squared minus 13 over 5 x plus, in parentheses, minus 6 over 5 equal to 0. Now on the board, we have vulgar fraction here, numerator, denominator. Vulgar fraction also here, numerator, denominator. Let's do the same thing here by dividing this term by 1. Alright, so we have vulgar fraction in all the terms on the board. The next is, what is the LCM of the denominator? The denominator on the board is 1, 5, and 5. So the LCM of 1, 5, and 5 is 5. Multiply each of the respective terms on the board by the LCM. Take note, LCM, the least common multiple or the least common or lowest common multiple is equal to 5. Therefore, multiplying this by 5, we have x squared over 1 times 5 minus 13 over 5x times 5 plus minus 6 over 5 times 5 equal to 0. So this is 5 times x squared gives 5x squared. Minus times minus is plus. So at this point, we have this cancels this. And at this point, we have this cancels this. So we are left with what is written in the bracket below. 13 times this gives 13x. Plus times minus is minus 6, which is equal to 0.